Latent heat of fusion and vaporization. To understand the concepts, let's take a look of heating curve of water. You can see the phase transition between solid and liquid here, and transition between liquid and gas here. The temperature of water doesn't change during phase transition. However, substance absorbs or releases heat energy depending on phase transition. For example, here solid-liquid transition. If substance melts, it absorbs heat energy, and if it freezes, it releases heat energy. You can see same phenomena this figure above. 0 degrees Celsius ice melts to 0 degrees Celsius water. The energy absorbed is described with red arrow, and if you go phase transition to opposite direction, water freezes to ice, the energy released is described with this blue arrow. The same principle applies on vaporization and condensation also. Latent heat of fusion means energy absorbed or released during phase transition between solid and liquid. And likewise, latent heat of vaporization means energy absorbed or released during phase transition between liquid and gas. You can see definition here. Latent heat is energy absorbed over mass of the substance. L is Q over M. Latent heat of fusion is noted L with lower index FUS, and latent heat of vaporization is noted L with lower index VAP. Let's take an example. We have 1 kilogram of water. We also know that latent heat of fusion for water is 333 kilojoules per kilogram, and latent heat of vaporization is 2260 kilojoules per kilogram. If you want to melt an ice block at melting point to liquid, it absorbs 333 kilojoules of energy. And on the contrary, if water freezes, it releases the same amount of energy. This plus sign here means absorption, and minus sign here means release of energy. The same principle applies on water at boiling point. During vaporization, water absorbs the same amount of energy as what water vapor releases during condensation.